Hello everyone, my name is E. Sai Kumar and I am from ECED section. My topic is integrated circuits for communication, and the content of my topic is the introduction and the types of ICs, the monolithic ICs, thick and thin film ICs, hybrid ICs, and their generations, and ICs advantages and disadvantages, IC packages. First, what is integrated circuits? A complex set of electronic components and their interconnections that are imprinted onto a tiny slice of semiconducting material. Integrated circuits are usually called ICs or chips. Integrated circuits were made possible by experimental discoveries which showed that semiconductor devices could perform the functions of vacuum tubes, and by mid 20th century technologies advantages in semiconductor device fabrication. The integration of large number of tiny transistors into a small chip was an enormous improvement over the manual assembly of circuits using electronic components. The integrated circuits mass production capability, reliability and building block approach to circuit design ensured the rapid adoption of standardized ICs in place of designs using discrete transistors. And the history of IC. An IC, also referred as chip or microchip, is a set of electronic circuits on one small chip of semiconductor material, normally silicon. This can be made much smaller than a discrete circuit made from independent electronic components. ICs can be made very compact, having up to several billion transistors and other electronic components in an area the size of a fingernail. The width of each conducting line in a circuit can be made smaller and smaller as the technology advances. In 2008, it dropped below 100 nanometers and has now been reduced to tens of nanometers. The structure of IC is given here, and the block diagram also. It contains AND gates, DRS, and here the system specification and the architectural design, functional design and logic design. And this is the circuit design, physical designs, physical verification, fabrication, and this is the chip. The types of ICs: monolithic ICs, thick and thin film ICs, hybrid ICs. Now let's go one by one. Monolithic ICs. A monolithic microwave integrated circuit, or MMIC, is a type of integrated circuit device that operates a microwave frequencies. These devices typically perform functions such as microwave mixing, power amplification, low noise amplification, and high frequency switching. Here is the structure and the figure is given of monolithic IC. Here, inputs and outputs on MMIC devices are frequently matched to a characteristic impedance of 50 ohms. This makes them easier to use, as cascading of MMICs does not then require an external matching network. Next, thick and thin film ICs. The general characteristic properties and appearance of thin and thick film integrated circuits are similar, although they both differ in many respects from monolithic integrated circuits. They are not formed within a semiconductor wafer but on the surface of an insulating substrate such as glass or an appropriate ceramic material. The primary difference between the thin and thick film techniques is the process employed for the forming the passive component and the metallic conductor pattern. The thin film circuit employs an evaporation or cathode sputtering technique. The thick film employs silk screen techniques. And the next, hybrid ICs, HIC. An hybrid integrated circuit, HIC, hybrid microcircuit, or simply hybrid, is a miniaturized electronic circuit constructed of individual devices such as semiconductor devices, and example transistors and diodes, and passive components, examples resistors, inductors, transformers and capacitors, bonded to a substrate or printed circuit board, PCB. Hybrid circuits are often encapsulated in prox. A proxy as shown in photo. A hybrid circuit serves as a component on the PCB in the way as a monolithic integrated circuit. The difference between the two types of devices is in how they are constructed and manufactured. And the next topic is generations of ICs. It includes SSI, MSI, LSI, VLSI, VVLSI, WSI, nanotechnology. Let's go further and know more details about it. Scale of integration. The scale of integration is for SSI we the number of transistors used are 2 to 64, and for MSI it is 64 to 2000, and for LSI the range is 2000 to 64,000, VLSI 64,000 to 2 lakhs, and ULSI is 2 lakhs to no limit. Small scale integration SSI. Normally it has about 20 components. The Minuteman missile and Apollo program needed lightweight digital computers for their initially guided flight computers. The Apollo guidance computer led and motivated the integrated circuit technology, while the Minuteman missile forced it into mass production. Medium scale integration MSI. It can have about 100 components. Medium scale integration came into industry in late 1960s. MSI is the next step in the development of integrated circuits after small scale integration. Medium scale integration allowed more complex systems to be produced using smaller circuit boards than in SSI. And next, large scale integration. It has about 1000 components. Yeah, LSI is a process of integrating or embedding thousands of transistors on single silicon semiconductor microchip. LSI technology was conceived in mid 1970s when computer processor microchips were under development. Very large scale integration VLSI. Very large scale integration. It can have about 10,000 components, and VLSI began in the 1970s when complex semiconductor and communication technologies were being developed. VVLSI, very large scale integration, also known as ultra large scale integration, and it can have about 10 million components in it. The ability to pack more electronic components onto a chip increases the computational power and speed of the computer or the other machine in which the chip resides. Wafer scale integration WSI. The evolution in semiconductor technology that builds a gigantic circuit on an entire wafer. Just as the integrated circuit eliminated cutting apart thousands of transistors from the wafer only to wire them back again on circuit boards. Wafer scale integration eliminates cutting apart the chips. Nanotechnology. Nanotechnology in the context of computer science is a type of engineering geared toward building electronic components and devices measured in nanometers, which are extremely tiny in size and structure. Nanotechnology facilitates facilitates the building of functional matter and systems at the scalar level of an atom or molecule. Nanotechnology is also known as nanotech. The explanation of nanotechnology. Nanotechnology works through different approaches to build nanomaterials or products, including bottom up, top bottom, and functional system development. In a bottom up approach, a product is designed as it evolves from its tiniest form factor to largest product. In a top down approach, a large product may be reverse engineered to develop product scale according to nanometer. A functional approach deals with a complete system and may incorporate bottom up and top bottom approaches. Now, the advantages of ICs. ICs are very small in size and they are low cost. They reduce power consumption and highly reliable, higher operating speed. It has higher operating speed and it reduces external wiring connections, and it is easy to use first. And the disadvantages of ICs are component dependent. limited capacitance, impossible to fabricate transformers, limited and it has limited power supplies, and it is not flexible. IC packages, it includes it can single inline packing, dual inline packing, zigzag inline packing. Single inline packaging SIP. A single inline pin package has one row of connecting pins. It is not as popular as the DIP, but has been used for packaging RAM chips and multiple resistors with a common pin. SIPs group RAM chips together on a small board either by the DIP process or surface mounting SMD processes. Dual inline packing. A dual inline package is an electronic component package with a rectangular housing and two parallel rows of connecting electrical connecting pins. The package may be through hole mounted to a printed circuit board or inserted in a socket. And the next, zigzag inline packaging. The zigzag inline packaging or ZIP was a short-lived packaging technology for integrated circuits, particularly dynamic RAM chips. A ZIP is an integrated circuit encapsulated in a slab of plastic with 20 or 40 pins measuring about 3 mm in 3 mm by 30 mm by 10 mm. The package's pins protrude in two rows from one of the long edges. The two rows staggered by 1.27 mm, giving them a zigzag appearance and allowing them to be spaced more closely than a rectangular grid would allow. Here are the symbols and the diagram of a representation of a zigzag inline packaging. Thank you.